Hey, welcome everyone. We'll start in a moment. Does the audio sound okay wherever? And if this is the first time you're here, leave a comment. You'll have to be logged in to leave a comment in the live stream to even like it. All right. So let's see what I can show you. All right, good. So you can see the screen. Let me bring up a chat on my phone. Hey, Mass Sensor, thanks for joining. Hey, thanks for letting me know, Vince. Thanks for joining. So I have so I'm a software engineer, right? Um, been in software, I don't know, ever since I got an Atari 800 XL when I was a kid. I think I was in the fourth grade or fifth grade. That was my first computer. Um, been doing programming since then. Haven't stopped. Um, we have it's like a new age now. You got all type of computer devices, whether it's a computer with what you would think with Microsoft Windows or a Mac with the OS, um, or tablets running Android or iOS, even the Amazon Fire, um, Kindle. You know your cell phones, whether it's the Google Pixel, whatever. Um, there's a lot of code that goes behind that to create first the framework for the operating system and then the applications. So this language, Python, is a language just like any other. You're able to create classes and program. Uh, you accept input, you have output. There's some calculations that go in between. So that's the typical life cycle of a program. You start it, it waits for input, or it doesn't. Maybe it just starts doing something right away. It performs a calculation and gives you output. And along the way, you may do that multiple times. Think of a photo editor. You know, the input is an image. It could be an image from your camera. You modify it. So this is kind of like that, but at a different scale where the the input may just be hitting the run button to start the program, and we're first going to get a window that's going to pop up and it's going to say whatever we want. So I'm working on a camera slider, and so I'm titling the window camera slider. I want to give you a run real quick just so that you can see what it looks like. And this is my first program, right? It's a little window that's running within Raspberry Pi. It has a title, Camera Slider V1.0, and it has a label. And I put my first label. And we can look. Here's the code. We have a window that we created. We have a window title that we're setting. And yeah, I wish. I've been gaining man sensor. So then here's the label. Actually, I do have tips. Don't drink soda like I do. That could be the first place you start. So we create the label, but it's not enough just to create the label. You have to do something to the language to say, place this label. So that's just a brief introduction to the code. I want to show you the device that I have. Let me switch my mode here to my camera. So this is, I'm kind of constrained by the cord. So this is what you're seeing on the screen. I'm connected remotely to this device. And this is a keyboard that I have plugged in, which I needed in the beginning to be able to enter some stuff, but it can be any type of USB keyboard. This is one that I bought with a Raspberry Pi that I'm using for my 3D printer. And that's the Raspberry Pi there. That's the Raspberry Pi that's connected to this 7-inch touchscreen. This is a touchscreen, so you can see I'm touching the screen and it's moving the mouse around on the screen. So setting that up was real easy. Raspberry Pi came with the kit that I bought. The link is in the description. It came with the memory card. I was able to program that memory card with an image using Raspbian. All those steps I want to go through. There's plenty of videos on that, but I'm going to create a series from beginning to end. I just wanted to jump right into this to kind of bring everybody's attention to how easy it is to write your first program. So Sherry's saying hi. So I have the Raspberry Pi is connected to USB power. I just got a power brick. It's plugged in, and it gives USB power to the power device. That's all it needs. It just needs a dedicated USB power, just like the same type of power that you would use to charge your cell phone or your tablet. Let's see here now. We're still streaming, right? Because it is weird right now. I don't know why it's not showing that. Let's go to my channel. All right, there we go. Now I got it. Hey, Martin. Thanks for joining. So everybody, Martin is from Iceland. Mass Sensor is from the UK. We got people from all over. Rover's out in Nevada. So we got worldwide. And I'm representing SK80 Woodworking. He's a woodworker, a maker, much like myself. He does some really cool stuff, so make sure you check out his channel. Alright, so about Python. So let's look at some of these other... I want to show you how you would do your first program. Let's make this window larger. Can I make it larger? Yeah, I can. Alright, so a little bit about this setup before I do that. This is running what's called VNC, and it's a virtual viewer. So it lets me see the desktop as if I had, hey Keith, it lets me see my desktop as if I were at the computer screen. So now I don't have to physically be at the computer. I can use this VNC program to connect to it remotely. There's plenty of videos on that, but I'm going to put together a whole series on how to go from beginning to end to get your Raspberry Pi up and running. And what this does is this program allows me to sit here at my computer on the big screen and do a live stream from it without... Oh, you know what? I need to show my screen. Let's see if we switch. You should see my screen now. Give that a minute to sync up. So this program here is VNC that I'm using, and this is what allows me to connect remotely to the Raspberry Pi. So let's say you have your Raspberry Pi upstairs in your office, and you want to be downstairs while you're sitting at the kitchen table. You can do that. You can use VNC to connect to it remotely. That way you don't have to keep moving things around because you want to program and set something. The Raspberry Pi can be used for infinite number of things. You can make a weather station with it. I'm using it to make a camera slider. So if you don't know what a camera slider is, a camera will sit on a trolley, and the trolley will be pulled along one direction or another direction over a period of time specified by me. And what I'm going to do in this series is I'm going to show you how I create this application from beginning to end. And I'm going to need inputs. And the inputs are going to be where I want the camera to start along this whole 8-foot length that the camera is going to traverse, and where I want it to stop. So start and stop, but I could make it so that it does more than that. Initially, starting point, ending point, the amount of time it takes to traverse that distance, right? So if it's got 8 feet and I want it to go 8 feet and I want it to take 10 minutes, it'll calculate the speed of the motor, which the motor will spin to make the camera slide across the screen. And I have what's called a stepper motor. For anybody who's watching who doesn't know what a stepper motor is. So this is a stepper motor. Let me switch to my camera. So that's a stepper motor. And the stepper motor allows precise movement based on a digital signal that you send to it. And it'll rotate in either a forward direction or a backward direction at varying speeds depending upon what signal you send to it. And this motor is going to be hooked to a gear. I'll show you the gear. So this right here is what's called the pinion gear. And let's see if I can show you that. It's got some teeth on it, right? And this is a belt that's going to connect to the pinion gear. And then this is the other piece, right? So this will allow the entire camera to move. This is only one part. I want to have a bigger belt that's going to traverse the entire length. But let me show you what that looks like. So this is what it looks like. So as this spins, right, I would have to spin this probably 66 times on the small one to make the big one spin, right? So that's just a little bit of math that has to be performed, and then I can specify what that speed is. So all that information has to be entered into this program. Hey, thanks for joining, Nick. So I need to create a label that's going to allow me to ask for start point, right? Or let's just say time, right? Time and end time. All right, so let's assume that our requirements are we want the camera to start at one end and we want it to end at the other end. So we're going to need an input for time. So if I run that, there we go. We have a label. Now that label doesn't do anything. Let's see if I can show you that. So that's just a label just sitting there. So now what I need is I need a text box. And there's a site that explains how to do, there's several sites that explains how to do a lot of this coding. And here's one of them. This is a Python Central. So now you can ask for an entry. And this is basically a starting point on how you create a GUI. Now a GUI, GUI, is Graphical User Interface. And it's where, it's this. So let me start and stop and start it again. So this right here is the GUI for the application. And I want this thing to look really cool. But I'm going to start out small. I'm going to start out where it just has some text, which is where we're at right now. So you start small, and then you keep adding a little bit, and you're pretty soon you have this large program that's like really awesome. And that's what I do every day, working on software. That's why I like it so much. Software is so rewarding because when you create something, you immediately see results. And then when that software gets in the hands of customers and they give you feedback like, wow, that's really cool. I mean, that really helps. Okay, so now I need an entry point. So like I said, you have, with any typical program, you have an input, which is where you enter information in. And my input's going to be what? It's going to be the amount of time. And let's say we want the time entered in seconds. So if I want 1 minute, I'm going to enter 60 seconds. If I want 2 minutes, I'm going to enter 120 seconds. And then there's going to be an output. Now the output can be graphical or the output can be physical. Think about a printer. You hit the print button. So that's your input, but the output is a piece of paper that has your homework printed on it. And that's a form of output. Yeah, that finished. I have to work on another one now, Keith. Yeah, I was really pleased with that one. That I went from knowing nothing about iOS to learning quite a bit. So thanks for asking about that. All right, so we have our entry point. So the entry point is what is going to allow us to input data that then this program can use. So let's see if we can add this. And we're not root 1, we're window, because that's what I named it. I named it window. You see that right there. But putting this here is generally not enough. I have to do one more thing to instruct it to display it. So we don't see any input there. So now I have to add this window.pack. Now let's see if we can get it to show up. Hopefully it'll show up. And I don't see anything. So this is the problem with programming. You try to do something, and well, guess what? I did it wrong. I have to type entry. Let's see if that fixes it. It's a lot of trial and error. So when you write your first program, there we go. Now we have something. You write your first program, don't get discouraged. Please don't get discouraged. So now I can enter something. Does it do anything? No, it doesn't do anything because I don't have anything to take behind that. And then other things I'm going to need on this program is I'll need a start button. So I have to add a button. And I have to learn how to add a button because I don't know how to do that yet. So we can look through this code to see if there's any suggestions on a button. And I don't see anything there. Let's see if we can go to how-tos. So we're doing this all together, and I kind of like this approach because it demonstrates that the answers aren't handed to you. You have to search for the answers. You have to do your own research to find the solutions. So let me do a little bit more digging. All right, I'm going to go to Google. There's another site that I had up, but I lost it. All right, let's see if we can add this button. Copy this code out. Okay. And then we are window. I don't know what's going on. Maybe it doesn't like something in this code. I don't think it likes something. Let's see, does it not like something? Missing parentheses and call to print. Okay, so they want parentheses. Let's see if that helps. Button is not defined. Okay, that button. Okay, so there's our button. So now what happens is every time I press this button, it's going to output click in the output message. So that's a form of output, right? It doesn't have to, that output doesn't have to be in the window itself where we're doing the work. Because remember, again, I said that your output could be in the form of paper coming out of a printer. It doesn't have to be on in the same window of the program. Your output could be a file that was created that you'll use another program to look at that file, like Notepad or WordPad or Microsoft Word or even Microsoft Excel if it's some type of number file. So let's change this text to just say distance, right? And we'll just put that for now because I wanted to maybe put the amount of distance, distance remaining. So what this is the camera starts at one point on the slider. And I'm not showing my screen. So the camera starts at one point on the slider and goes along, and at some point it's going to stop. And I might want, so let's put, that'll be where the number will show up. And then I might have time remaining. If I could spell. So that'll be the amount of time in seconds, right? And we'll just put that there. So it's just going to print out n and t. I'm not going to have any numbers there for now. So let's hit start. And I hit OK. And look, it just printed out on the screen. So now I have a form of output that's going someplace that I can monitor the program with. I really want that output to go onto the screen though. And what I need to figure out is how to get the text from this text box. If I put in that number, I want that to show up down here someplace. Now, I don't want this to be an OK. I don't want it to say OK because I want this to be a start. So let's make this run, or let's just call it start. Right, so now it's going to start the program. And this is the camera slider, right? So that's what we're doing. We're starting the camera slider. So you enter the time in and you start it. But what if you don't enter the time in and you hit start? It shouldn't do anything, right? So we have to do that too. We have to check. We have to check the values to make sure that the right value is entered. Because let's say they put in that. Is that going to work as a value for a number? It's an edit field that a user should be entering a number, not entering text. So we have to block that too. There's a lot of cool things we can do with Python. And I have yet to learn because I'm just starting Python, much like you're just sitting here watching, learning for the first time. Now I know how to program, and I've been through many different languages. This is the first time I've used Python. So the first program language that I learned was BASIC, and then I learned assembly, and that was on the Atari 800XL, which that was a Motorola processor. I think it was a 6502 processor, if I'm not mistaken. It's been a long time since I played on that. And then I moved over to C++, and so there's many different languages. And you're not going to learn just one language if you're doing this. You're going to learn multiple languages. Now I want to show you another approach to writing a program. So this is a command line that you can open up from within Raspbian. Again, this is Raspbian. It's the same operating system that's running on that touchscreen there. And I can just type Python. Right, and then I think I can type print hello world. There we go, look, I just printed something. So this language runs in another way. It could run from within this Python program. And this is just a terminal that I'm using to access that program. So many different ways that you can run Python. What I'm doing right now is I'm just using this this little mini IDE to let me edit and run the Python script. So the Raspberry Pi is a single board computer. It has USB ports that let you plug in USB devices. I have right now a keyboard plugged into the USB port. It also has an HDMI port that I could use that HDMI cable to plug it into a TV. You can use a Raspberry Pi to play movies from if you load the right operating system. A lot of things you can do with a Raspberry Pi. The thing I like about the Raspberry Pi is you can use it to write a program separate from Microsoft Windows or iOS or OS X in the Mac, or separate from Linux. You're writing something in a separate program that's kind of confined to what it can do for you, and it lets you just play around without having to worry about too many different things. What is an IDE? Okay, so an IDE is an integrated development environment. Yeah, I apologize for that. I'm speaking a very large language using acronyms. So this right here is confined to allow you to write a program and execute the program immediately. It gives you, and it's a small, lightweight, integrated development environment. In this method here that I was showing, I would have to use an editor, a text editor, to create a program in Notepad or whatever, save it, and then use the Python program to execute that program, to test it, to see if it's working. Here, it lets me edit directly. It lets me edit the text file directly in this window. It gives me instant feedback if there's a problem. Because you can see here, it was saying that button is not defined, missing parentheses around the print. So I had to add the parentheses around this print. It gives you feedback. So that's part of what the integrated development environment means. It kind of makes everything easier for you. I'll take you back, why this is important. I'll take you back to development in like the 80s. You would have to use an editor. You would edit your file, and then you would use another program, whether it was an interpreter or a compiler, to create the executable, and then you would have to run it to find out if your program worked or not. And then you would have difficulties along the way where it may not run properly, and it would just really, it was really slow. Now, the term IDE is used in the software industry as a all-in-one almost, where you can do your code, write your code in several text files, modules you can call them, and then in this case it's an interpreter, so it's interpreting the script language, running the script language. It can run it, and then it can give you feedback along the way if there's a problem, or in this case, you can place information by adding print statements throughout your code that says, I did this or I did that. Let's say your program crashes. Now what that means is the program stops running. You could put a print statement in at different spots in your code that says, I made it here, I made it here. And that way, if the program crashes, you'll know that you made it to step number 5 that you printed out, but you didn't make it to step number 6. Okay, so I know that my problem is in between the print statement 5 and the print statement 6. And there could be 20 lines of code in there, and you have to find out what your problem is. So that's another way how the IDE helps you. So it's all this immediate feedback. and it's a nice introduction to programming. So if you don't know anything about programming, I don't think it's going to be overwhelming for you at all to get the Raspberry Pi. The kit, if you get the kit, it comes with a memory card. You could use any USB keyboard and mouse for it. If you have an HDMI cable, you can plug the HDMI port from the Raspberry Pi to a monitor. Most monitors today have an HDMI port on the monitor. Most TVs in our homes have an HDMI port. So you can plug the Raspberry Pi directly into your TV. And instead of watching TV before you go to bed, maybe you can stay up and write some code and try out your new thing. So I hope that that answered your question, Jennifer. So what I have to do, I have this board here. This is a board for 3D printing, and I'm going to control this board with my Raspberry Pi. I'm going to send commands from the Raspberry Pi using Python. So I'm going to write a very complicated program that will send messages to this device over a serial port to instruct it to control the stepper motors. So the stepper motors, let's see if I can get the stepper motor. So the stepper motor plugs in, it's already set up where it just plugs right into this, just like that. So now it's plugged in and it's ready to be controlled. I just have to get power. So I'm waiting to receive the power supply. And then I'll be able to start designing and building the camera slider using the components that I showed you and this 3D printer board. I want to see if we can switch over to. Let's see, we're still on me, so I'm going to see if I can switch to the 3D printer. Right, so okay, so this is my 3D printer. Now this camera, that you see there is being fed through another Raspberry Pi. Let me see if I can show you that Raspberry Pi. So that right there is the Raspberry Pi. And that's running a piece of software on it that's called Octoprint. So Octoprint was created to allow us in the 3D printing community to send commands to our 3D printer more easily than having to transfer them through another method like burning an SD card, and it's just really slow. So this really helps out a lot, and that's how you're able to see that. So the 3D printer is controlled by a board, much like the one I just showed you, by a board similar to that right there, and it's also connected through that little USB-B port that you see there sticking out on the bottom right, the white connector. It's connected to the Raspberry Pi. So again, if you're slightly interested in programming, you already have a computer where you can start programming now. I just think it adds a level of funness to programming by using a Raspberry Pi. Now I want to bring your attention to James Print and Play. He created a, let me look it up on his channel. Now he's not the only one who's done this, other people have done this. He created an arcade. And I'm going to wrap up here in a few. I just want to find James's Print and Play. So now if you aren't already, let's see if we can switch now to this. This will be Inception now. Alright, so showing your live stream during my live stream. Promoting your arcade RetroPie. So he's got a 3D printer right now. It's a Delta 3D printer printing out. So if you don't know anything about 3D printing, it's really awesome. So let's jump on over to his videos where he created an arcade cabinet. So 3D printed arcade cabinet. Now this, I believe, was done with a Raspberry Pi. Let's turn the volume down. And so I think I swear he did this with a Raspberry Pi. Just want to jump ahead a little bit. So the cool thing about this is you can get all these components off of Amazon too. You can get them off of GearBest. He's got the links here for all the GearBest stuff. All right, so let's see. And it looks just, I mean, this is how cool this is. This was 3D printed. The whole thing was 3D printed, right? And he's got the LCD screen there, and you're able to run these older arcade games. So if you didn't know if you didn't know you have the capability of running these older arcade games, you actually do with the Raspberry Pi. And you can have different ROMs, so you can pull out the, what I mean ROMs, you can have different memory cards. One memory card for playing with your Python stuff, and another memory card for using RetroPie. So you don't have to keep buying a separate Raspberry Pi. You could just switch out the memory sticks. Okay, so he's using an Orange Pi. And then I'm just asking him one last question, and then I'm going to end in a minute here. So if you found it helpful, give this video a like. If you didn't find it helpful, give it a dislike. This is something that I plan on doing more of. It's going to be planned out a lot better. I'm going to have a video series I'm going to create for this where you're going to have your initial, okay, I just bought the Raspberry Pi. How do I set it up? Then how do I connect to it remotely using VNC so that I can get to the point where I can start programming. So what James is saying is that the Orange Pi is slightly different than the Raspberry Pi It's they're not exactly compatible, but there's software that's been ported between the two. But there are definitely people who are using Raspberry Pi for arcade setups like this. And his point, he's from Canada. His point is that it's cheaper in Canada to get the Orange Pi than the Raspberry Pi. Hey, Sean, thanks for joining. I'm wrapping up in a minute here. So again, make sure you subscribe to Print Play. He's got a lot of cool stuff that he's working on, tinkering with 3D printing, programming. And make sure you visit back when I work on the next version of the camera slider. And that's something I'm going to have at Murph. It'll be 3D printing related because I'm going to use a 3D printing motherboard to control it. So, thanks everyone for joining. Have a good night. Hey, Matt. Okay, yeah, so Matt's saying that RetroPie was made for the Raspberry Pi first, yeah. Then it was ported over to the Orange Pi. Yep, cool. So Raspberry Pi is definitely awesome for learning. And you get your own little computer with your own operating system running. And you can launch, you can use the free Microsoft Office equivalent called LibreOffice. You can launch the internet. So I can bring up Chromium and I can go to any place on the internet. So let's say I go to Google, spell it correctly. So there you go. That's how easy it is. It's running Linux, and it's a distribution of Linux. And you can even do Mathematica on here. So if you don't know what Mathematica is, you can actually solve mathematical problems with basically using another language. So I can do, let's see if I can type in here, plot, and then let's see if I can run. Will it let me run this? Open formats of evaluation. Oh, I think it's X this way. And I think I need to specify the domain. Been a while since I used Mathematica. Cannot be followed by f of x. Let's do help, online documentation. And this is all within the Raspberry Pi. So I can look up how to do the plot function. Okay. So I just need my function. There we go. That's what I'm doing wrong. So that's my function. And then I just need this here. Or not. So I need brackets. Square brackets. And why isn't it plotting? Maybe it doesn't plot on this. Oh well. That was just a little side direction we took there. Generates a plot of f of x from, yep, I did all that correctly. And it just didn't do it. Oh well. Anyway, thanks for joining, and hit me up on Facebook or Twitter. And don't forget, you can buy me a cup of coffee. That's in the description of the video. Let me see if I can find it. Let me go to info. And don't forget, I got merch. You Do It has merch. There we go. That's my store. All right. Thanks for watching, everyone. See you.